My goal in making this video is to provide some clarification on the issues surrounding women's amateur boxing in the Olympic Games at the moment, and particularly the controversy that's swirling around the Algerian boxer and the Taiwanese boxer. So quick disclaimer: if discussing genitalia makes you squeamish, click off this video. If this whole subject is going to upset you, click off this video. And lastly, if your parents don't want you to listen to these kinds of videos, then please adhere to your parents' wishes and click off this video. Now, I want to try to avoid as much as possible any of the so-called politics, but at this point, that's what it's devolved to. This conversation is just turned into mudslinging between media outlets, between the International Olympic Committee and the sort of semi-ousted International Boxing Association, which is supposed to be the international governing body for amateur boxing. So as the woman who fought for women's inclusion in the New York City Golden Gloves back in 1995, I am most definitely someone who stands for inclusion in sport, particularly amateur sport, because that's where our rights are protected. And I also stand for absolute fairness on the playing field. So that said, let me list right off the bat what the problem I have with the IOC's statements. They brush this off simply by saying, well, these women were born female and it says so on their passport. Okay, so any of us who are a little bit savvy, like New Yorkers or Angelinos or really anybody anywhere in the world who's lived in a big city, you know that if you have enough money, you can acquire government documentation that says whatever it needs to say. In fact, I've even acquired incorrect government documentation based on the government agency's error. So, point being that what it says on your passport is not evidence of your gender. Second thing they're saying is, well, these women were born female. Well, okay, that's fine, but at this point we do need to provide some type of scientific evidence, because saying so and gender identity, is not sufficient. Now, you should know that prior to the 2000 games in Sydney, the IOC did permit the cheek swab, which meant athletes would swab the inside of their cheek. That's the easiest place to sort of collect skin cells. It's relatively non-invasive and not painful, and then those cells would be analyzed for the athlete's DNA, and then determine, if they possess XX chromosomes, which indicate that they're female, or if they possess XY chromosomes, which would indicate that they're male. Now, it's being sort of put out there, perhaps not so much by the athletes, but by other media outlets, is that both Khalif and Lin are what is now called difference in sexual development, or DSD. Now, we used to call that intersex, and prior to that we used to call that hermaphroditism, but both of those terms are deemed politically incorrect. So now we use the term DSD, difference in sexual development, and so I will use that term DSD. Also, because if you want to do some of your own research, the most recent research will come up if you use those keywords, DSD, difference in sexual development. Now, within that broad term, DSD, there's a number of possible sort of types of DSD, and I will get into that momentarily. And really the only way to detect or verify DSD would be through a genetic test, meaning you would need to do the cheek swab. And in its wisdom, the IOC, International Olympic Committee, decided starting in 2000 that they were no longer going to use the cheek swab test. So to understand a little bit about what DSD is, it is not someone who is transgender, meaning someone who made the objective decision to live their life as the opposite gender than what they were assigned at birth. DSD is a genetic condition. And so to discuss DSD, I will have to kind of backtrack a little bit and review a little bit of high school biology with you guys, because we want to understand what the terms mean. So stay in school, kids, listen to your teachers so you are armed with information and can make your own informed decisions when you get a little bit older. And so that you have a relevant scientific basis to back up whatever arguments you wish to put forth. So there's my little rant. But let's look a little bit at the terms DNA, chromosomes, XX, XY. What does this all mean? Okay, so we'll start with DNA, which stands for deoxyribonucleic acid. So the ribo refers to the ribose molecule, and nucleic, the DNA is in the nucleus of every cell of your body. And it's called an acid, not because it's acidic like lemon juice or battery acid or something like that. It's called DNA acid because there are molecule groups on this molecule called DNA that categorize it as an acid. So specifically, the acid group is a carbon double bonded to an oxygen and an oxygen bonded to a hydrogen. We call the oxygen bonded to the hydrogen an alcohol group. Now I'm telling you all this just to give you sort of the bigger picture. In chemistry, we categorize molecules such as acids, ketones, sugars, etc., just so we can understand how these molecules might interact with each other and react to produce a new substance. So the fancy word DNA is simply the chemical name of that molecule. Here's another example. So you use table salt all the time, but the chemical name for that would be sodium chloride. Nobody's going to call it that, they're just going to call it salt, right? But sodium chloride is the fancy chemical name for it. Same thing with DNA. All right, now, what are genes? Well, genes are, GENES, are just a specific part of one strand of DNA. So, you get half of your DNA strands from the female parent and half of the DNA strands from the male parent. There are 23 pairs of DNA strands in total, and let's just look at 22 of those DNA strands. 22 of those DNA strand pairs. So 22 of them just are programmed with the code for your physical, and some would say mental or emotional and behavioral attributes. For example, on a specific DNA strand, there'll be a section that's a gene for your eye color. Now, as I said, you have one DNA strand from the male parent, one DNA strand from the female parent, and those pairs match up, or those two strands match up to make a pair. And that gene for, say, eye color will be in the same place on each chromosome. On each DNA strand. So we've now figured out which parts of each DNA strand correspond to different human traits. Now, some physical traits follow what we would call that classic dominant recessive rule. So, for example, eye color is the easiest one. Blue eyes, or blue eye color is what we call a recessive gene, whereas brown eyes would be the dominant gene. And there's no value judgment on this. It's just dominant and recessive are the terms that biologists use. So, in this case, if somebody has blue eyes, that means they got two recessive genes. They got the gene for the blue eye from both the male parent and the female parent. Now, on the other hand, if you have brown eyes, that's more than one possibility. That means you could have a dominant brown gene from one parent and a recessive blue gene from the other parent, but because the brown gene is dominant, it will prevail and the offspring will have brown eyes. The other possibility is that the offspring inherited both two brown dominant genes from one from each parent, and so again, they will have brown eyes. Now, other physical traits, such as your hair, follows what we call more of a mix rule. So, in other words, if straight hair and the other parent has very curly hair, the offspring will likely be born with wavy hair, somewhere in between, a mixture of both. So the important thing to remember is that all of these DNA strands are found in every single cell of the human body. Now, I'll make a little boxing analogy. Let's pretend that the DNA strands are your hand wraps, but they're unraveled. And you have 23 pairs of these hand wraps just kind of mixed up, all unraveled. Well, that's what your DNA is typically looking like inside the nucleus, inside every cell of your body. But when a cell goes to duplicate itself to make a new cell, that's when the DNA strands form into what we call chromosomes. So as you know, the cells of your body are constantly dying off and being replaced. Skin cells are probably the easiest for you to sort of witness, because anytime you have dry skin, right, it just flakes off. Those are dead skin cells, so your body knows it needs to replace those skin cells. And so your living skin cells are instructed to duplicate themselves. And when they duplicate themselves, they have to pass on that same blueprint for you to that new cell. So the DNA has to duplicate itself, or be duplicated. I'm not going to go into that process because that's not really germane to this conversation and it's complicated, but you can certainly find plenty of videos that illustrate this whole sort of awesome and fascinating process. Now, the relevant thing for you to know is that DNA, deoxyribonucleic acid, is exactly the same thing as what we call chromosomes. Imagine you take your hand wraps, your 23 pairs of hand wraps are just all mixed up and unraveled, and then you roll them up and put them into nice, neat pairs. Well, the nice, neat pairs of hand wraps, that's what chromosomes are. The DNA only turns itself into these nice, neat bundles called chromosomes when it wants to duplicate and divide. So even though that's not how your DNA looks the majority of the time when it's in your body, this is how textbooks will illustrate DNA, just because it's sort of a neater, more organized way to draw DNAs in terms of the chromosome form. So there's no difference between DNA and chromosomes. The chromosomes are just a format of organized DNA. Just like your hand wraps are still your hand wraps, whether they're unraveled or they're rolled up. Okay, so remember I said we all have 46 strands or 23 pairs, and 22 are devoted to the blueprint for your physical and perhaps behavioral or mental makeup. So what about that 23rd pair? This is what's crucial to this conversation. That 23rd pair are what we call the sex chromosomes. Again, you get one from your mom, one from your father. Now, the female parent can only donate an X to the offspring. The male parent can donate either an X or a Y to the offspring. So if the offspring winds up with XX, they are female. If they have XY, they are male. So I hope that gives you enough of a sort of basic background to understand the difference between what we're saying about DNA and chromosomes and XX and XY. So here's where the DSD conversation can start. In terms of DSD, there's some sort of irregularity with the XX or XY chromosome in terms of either the makeup or how certain parts of those chromosomes then get activated. Some of you may have heard the sort of saying that your genes or your genetics puts the bullet in the gun, but it's the environment that pulls the trigger. So again, just looking at the 22 other chromosomes, let's say you are genetically programmed to be susceptible to some type of heart disease. Well, if that's the case, okay, you're genetically programmed that way, but you can environmentally, in terms of how you take care of your body, deal with that to avoid that predisposition being, as we say, triggered. Now, in terms of DSD, I've done some research in terms of looking up papers on PubMed, and the first thing you need to know is that there's more than one type of DSD. It's an incredibly complex set of conditions, and it's an incredibly complex field. There's a variety of ways that DSD can show up in a human body, and then, the sort of treatment, if you want to call it that, that's incredibly complicated. I'm not going to get into that, and the causes, I'm not even going to get into the cause of why forms of DSD can occur. Quite frankly, I don't understand that myself, but that's not really the issue we're looking at here. I think it's important to just understand what DSD is. So as I said, there's multiple forms of DSD, and the range I looked at, it ranges from 1 in 450 cases to 1 in 100,000 cases. So right now, they've put DSD into 3 broad categories. One would be an XX disorder or dysfunction. One would be the XY difference. And finally, just a sex chromosome difference, which is the rarest type. So very generally speaking, if there's an XX difference, that means typically the ovaries don't develop normally. If there's an XY difference, that means the testes don't develop normally. If there's actually a sex chromosome difference, and this is the rarest form, it can mean that either there's both XX and XY chromosomes present in one individual, or it can mean that they lie beyond the XX and XY categories. For example, someone can be born with just an X chromosome, that's called Turner syndrome, or they can have an XXY, and that's called, I think, Klinefelter syndrome. Now, here's the issue with regards to these 2 Olympic boxers, Khalif and Lin. It's been written, or I've seen it written, that supposedly the IBA stated that they failed a gender test because they possess XY chromosomes. But in this latest sort of press conference, the IBA just said it's not allowed to reveal any information, which may be true. Perhaps the governing bodies for Algeria and Taiwan said, hey, you know what, IBA, it's all well and good you did these tests on all the boxers and made a determination for the world championships, but you don't get to disclose. This is personal information. It's medical information. you don't get to discuss it any further. Okay, but here's the real issue at stake. So let's take a look at the two more common forms of DSD, which would be an XX irregularity or an XY irregularity. I think in both cases, it's safe to say that the baby would appear with what we would have to say are abnormal genitalia, meaning perhaps male genitals are incredibly small, or the testes have not descended, meaning they're still up in the abdomen. As a fetus develops, the testes drop and become external to the body, but it's possible for someone to have undescended testes. In terms of the XX irregularity, that would imply that the ovaries don't develop normally. The uterus may also not develop normally. So I'm guessing that when people make the claim that these boxers were quote unquote born female, the thing is, when a child is born with DSD, the doctors and the family, I'm sure there's like a whole team of professionals involved, but a decision sort of needs to be made, at least on the part of the family, in terms of what do you care to do with this child? Do you care to have some type of surgical procedure? How will you raise your child? And to say that the child was born female, that to me means that the family says, okay, we're going to raise this baby as a girl. But that's not necessarily an indication of their genetic gender. And I mean, I don't think any of us really want to know all the specific details of a family's decision as to why they chose to raise this individual as a girl. That's not really relevant. The only thing to me that's relevant is, well, do they actually possess XY chromosomes? And here's the importance in terms of sport. Because if an individual has undescended testes, for example, but parents have chosen to raise this individual as a girl, that's all well and good. But at a certain point, like when they hit puberty, if they have more testosterone being produced in their body, we know that testosterone spurs muscular development, it increases bone density, it certainly produces certain skeletal structural differences between a male and a female, wider shoulders, narrower waist. So the question really is, if someone with DSD who's been raised as a female also goes through puberty with a surge in testosterone, they now physically have an advantage over other female athletes who went through puberty as a female. And because these are basically structural differences in terms of the skeletal structure and the muscular system, these are not necessarily reversible. Certainly the skeletal structure is not reversible, the bone density is not reversible. And even if it were, it might be dangerous for somebody with DSD to just start, ingesting hormones to try to change their physical appearance. That I don't know anything about, but I also don't think that's sort of relevant to this conversation. I mean, the final aspect to this, if this is an XY DSD person who was raised as female, is their body still producing more testosterone than a female body would be? Because again, if that's the case, they do have an advantage over the females. I'm going to jump back in time to 1996 because I sort of there was a DSD individual who fought as a female judoka. Her last name was SILVA, and I think she fought in the minus 72 kilograms division and later moved up to minus 78 kilograms. But according to a French publication called Libération, there were, people questioning her gender all the way up to 1996, and initially the judo officials in their brilliance decided to do an eyeball test on all the women in the same weight division, which was, I'm sure, humiliating because it involved the women lying on their back on a table and spreading their legs for the officials to make some sort of judgment, which is completely horrendous decision. But according to La Libération, or Libération, this Brazilian judoka, last name SILVA, did undergo 2 surgeries prior to the 1996 Olympic Games. Supposedly she had female genitalia reduced and testes removed. Again, this is according to Libération from France. Now, in 1996 at the Olympic Games, they were still doing the cheek swab test. And according to a USA official whose word I trust, because he's an academic with a PhD and has nothing to gain by giving me false information because we were just having a conversation. He told me that her cheek swab test came back where she had exactly 50% XX and 50% XY. So SILVA fell into that rarer category of DSD where there's both types of chromosomal makeup present in one individual. And so the official told me, hey, you know what? She came back 50-50 with the chromosomes, so we have to give her her choice, and so thus it was. But I think that part of the reason this didn't turn into a furious debate was that SILVA was not really dominant at that world-class level. She wound up placing 7th at the 96 Olympic Games, and that's not to take away and say, oh, that's nothing great. I mean, if you can make an Olympic team, you are awesome. I mean, go represent your country at the Olympic Games. That's a lifetime achievement, regardless of whether you place or not. But point being, maybe if she had absolutely trounced every single judoka in her weight division, then there might have been more of an uproar, so to speak. But even at her, there was no real sort of protest from any of her the fellow competitors. Regardless, I guess my whole point of this is that I really don't know what other test, other than doing the cheek swab test to check for genetic material, what other test can we possibly use. We have no other way of collecting valid data to determine if an individual should be competing in the female division or the male division. Now, levels of testosterone are a factor, obviously, but they don't dictate, or they're not indicative of somebody's gender. They're just indicative of the fact that someone's body might be producing more testosterone than the average female or less testosterone than the average male, but your hormone levels fluctuate throughout your lifetime. Your XY XX chromosomal makeup does not change throughout your lifetime. So in summary, what I'm saying is I think that if we really want to establish some sort of level playing field, we do need to go back to the cheek swab. We do need to determine if somebody is in fact XX, XY, or has a mixture of both. And if they do have DSD, then I think that needs to be determined on a case-by-case basis, because of the range of ways that DSD can manifest. It's not a one-size-fits-all. We can't just make an arbitrary rule and say, oh, well, if you have DSD, you know, you must compete as a male or you may compete as a female. That's absolutely not fair. And although individual athletes may feel it's a little bit of a violation, so to speak, of their rights to disclose medical information about themselves, well, if you fall into that category of having DSD, I mean, I would hope that you want to compete fairly in your sport that you're so passionate about. And so, yes, although you're giving up personal information, you know that you're different, you're unique. In this particular case, if you want to play on a level playing field at the global level or even at the national level to make the Olympic team, you're going to have to give up some more additional information about yourself so that we do have a level playing field and everybody is included on a fair playing field. So that's my take. Please let me know if I can clarify anything further for you. Here's the thing with DSD, because we're dealing with like less than 1% of the population, when it comes to that specific exceptional cases, that's where you really need experts. Like, I'm not an expert on DSD, but I do understand basic biology enough just to sort of set you up to hopefully understand what's going on here and the difference between what these terms mean, like DNA, chromosomes, XX, XY. So again, please post any questions in the comments area. I'd like to really avoid any sort of mudslinging or politics in the comments. So, you know, you can post those sort of political or whatever ideas perhaps elsewhere. But please, let's just try to keep the conversation as objective as possible. So thank you very much for listening. Let me know if you got something out of this video. I appreciate your time.